Thank you for this opportunity to talk about my deployment to California this past summer to serve as an air resource advisor for this August complex fire. This fire was situated between Redding, which to the north, and Sacramento to the south, just west of the Central Valley. For EPA, my expertise is in geospatial realm, mostly remote sensing GIS. I have a forestry background, so I'm very much involved in examining vegetation structure and land cover dynamics as it pertains to air quality and water quality. I'm one of the PIs right now for the Wildland Fire Research Program within the AIR program. Want to mention that the ARA program is a multi-agency effort to train and deploy technical experts to wildfire incidents, where we can provide expertise in forecasting smoke dispersion on a daily basis. I was trained last summer in Boise. I was mentored by an experienced ARA on the Springs fire last September near Mammoth, California. That was a smaller fire. This year I finished my trainee program and was promoted to a full-time ARA on this August complex fire, a very, very large fire. And so we'll begin here. Here's a slide showing the fires that occurred within California this past summer. A very large year, one of the bigger years, at 4 million acres, 4% of California burned. And that actually was the normal back in the 1800s. They would burn between 4 and 12 million acres. And so it was a very big year, a lot of smoke produced, yet it was a big year for us. I want to give a little bit of background as far as what an air resource advisor is. You guys can read the bullets, but I just want to mention that I think I mentioned earlier, but we're trained to be dispatched on different incidents to assist in the prediction of smoke impacts on public and fire personnel. And that's our main priority is first and foremost, the fire personnel, keep them safe, but also for the public. We analyze, we summarize and communicate these impacts to the teams, the incident management teams, also to different air quality regulators. California has a large conglomerate there, and to the public. We are known, ARAs are technical specialists and with different expertise, areas of expertise. They may be meteorologists, they may be, as I am, just a geospatial forestry person. They have air quality monitoring experience, smoke modeling, pollutant health thresholds. A myriad of people come together for these ARA positions. The primary responsibility is to provide this timely smoke impact and this information and messages based on the best available science. We work with these incident management teams with the public information officers, which I'll show you in a minute, PIOs, with the FBANs, the IMETs, who are the weather folks and the vegetation folks, as well as others addressing these smoke issues. We coordinate with multiple agencies to address public health risks and concerns, risks to transportation safety and fire personnel exposure within these base and spike camps. And this is a slide that just shows the primary folks that an ARA works with is to establish a rapport with the PIOs, and especially with the FBANs and the IMETs, these fuel behavior analysts, and the IMETs will become your best friends in a lot of ways. As far as professionally, we work together to try to predict what's happening with these different elements. And then the safety officer too, we have to be able to coordinate with them and when things are dangerous, especially for carbon monoxide, as well as the firefighters on the front line and also for traffic safety too. I want to put this in, here's a typical day within an ARA's life, for me at least. I'm up early because I'm still in Western time, but have to be up early enough, 04:30, basically get up and grab a cup of coffee, parameterize the smoke dispersion models. I use Blue Sky and High Split. There are a number of others that are used also, but these are the two that I'm familiar with and I like the most. And then also check the daily weather. And then we also look at the monitors, the current readings for what the air quality is. And then finally begin to edit what's known as the smoke outlook. That's our primary product, and that's due out by 8 o'clock and published so that it has national exposure, and that forecasts the air quality for that day. And then for 30 minutes early at 7:30, I go down with where the whole team is stationed and be able to either be tasked to give a briefing on what the smoke is doing or listen in on all the different aspects of what the mode of attacks are that day for the fire and what the conditions are. I do want to mention that with COVID this year, we were in a place where we weren't directly in the camps, which we usually are, the spike camps or the base camp, in tents and living amongst the firefighters. This year we were in hotels and working long distance. So these broadcasts of the briefings would go directly out to the field where the folks in the field would get that information. And then publish the outlook by 8 o'clock, and then get on a number of calls for the state and for our ARA program in the afternoon, and finally another briefing in the evening. And then the other times are used to interact with the FBANs, the IMETs, and other folks to find out, if we needed to do some more modeling runs. A lot of it is driving to different areas to find out how the smoke is channeling and how it's dispersing. And so it's a lot of information gathering, or it may be a public briefing that comes into play. But basically, these are 18-hour days, not a lot of time for anything else, and you're definitely spent by the end of the day. All right, so here's a slide of some of the modeling. And on the right side is blue sky, which many of you may be familiar with. I would run blue sky and the high split on both the northern and the southern section of this fire. I'm going to get into the size of this. This fire was mammoth. It was very, very large, and so the smoke was behaving differently in different places. So in the southern section, you can see the blue sky run. It was mostly a chaparral, oak, shrub area that was highly flammable, and it behaved a little bit differently, would channel through the terrain mostly. And then we would run the high split that shows you could run the high split and look at the trajectories of the smoke at different altitudes. And so I would run the ones that would hug the ground the most, right at ground level up to 10 meters. I wanted to see how the smoke would behave in that way. One of the things I do want to mention of lessons learned is that the lower atmosphere smoke sometimes behaved 90 degrees different from what the upper level would do. Based on the fact that it was following terrain levels. It wasn't following the normal trajectory that was up on the upper levels. So this is a smoke outlook. I've just cut and pasted so it doesn't look like this directly, but these are the elements that are in it. We would give a brief overview of what the fire was doing that day and what it did yesterday. We talk a little bit in the briefing about what the smoke should do across the whole area. There's a map that shows the different monitoring sites that surround the fire. And so on this fire, we had 13, and they are established by the state. If you're in the state of California, you don't need to worry about setting up your own monitor. And if you're in need of another monitor, they have different agencies that will be able to place them up for you. Fires outside of California, we are trained to set up these monitors and so that the information can be relayed through satellite and downloaded for our use and for the public's use. So this fire would have these monitors. We'd make our forecasts based on the smoke modeling. We'd give a little briefing, little bit on what it's going to be doing at these different sites. And we all probably are very familiar with the air quality index rankings there. So in the morning, we would have a briefing. It would be broadcast, as you say, out to the spike camp. Here's the spike camp, and you can see the monitor right here. And they would ask us, the lead for the incident management team would come and talk to us directly, the ARAs, to say, do you have anything of value that you'd like to speak about that day? And if we had something that would impact the firefighters or public safety, we would speak very briefly. One thing we learned early on is that don't be a man of many words or a woman of many words. They are This is run like a military type of thing. I do want to mention the teams that we were part of. The Alaskan team, which came in the second part, was awesome, as was the first one when I was down south. Very much valued our work as ARAs. So one of the moments too is public briefings. I gave 2 public briefings, one in Reading and one down in Willow. And I spoke to the communities regarding how the general smoke behavior was, talked to them about their normal activities, relating it to just their normal lifestyle. So quickly talking about the fire itself, the fire was massive. Like I mentioned, over 1 million acres across 7 counties, and had been described as larger than the state of Rhode Island. And there's the state of Rhode Island's boundary imposed really on top of where the fire was. The fire is just north of here, almost to Hayfork, comes on down, not as far to the west, but then really cuts over where Willow is, and then hugs this Central Valley line. So it began as a series of 38 fires that merged, the primaries being the Doe and the Elkhorn, which merged on the 11th. I was on this fire beginning on the 13th and was there until the 27th. We also had a very big day on the 27th, the day that I left. There was a big shift in wind, of dry wind from a high pressure system that it shifted everything over. But there was, prior to me arriving, just a couple days before, there was a death, a firefighter death. There were just under 1,000 structures that were destroyed. The fire was mostly centered on the Mendocino, which you can see here in this kind of pale green, Mendocino National Forest. And just north, you get the 6 rivers and the Shasta Trinity. You know, what I do want to mention too is these sites are where our air quality monitors were situated. And, you know, they have the traditional, you can tell they're bad air days by the different coloration. So you've got the red, which is indicative of unhealthy air. And we would monitor these obviously every day to get this out to the public. And so going back, I wanted to show this is that we generally had 2 different areas. We had a northern section and a southern section. We had 2 different, fire was big enough to have 2 different incident management teams. We had one situated in Reading and then one down in Willow. And we managed the southern section when I first arrived in Willow. I was there for about a week and then moved up to Reading for the second section the last week to manage the north. So smoke was, on this day, you can see it's a very unstable atmosphere. The smoke got off the ground and into the atmosphere is really what you do want for air quality. And then we had a very bad day on just prior to me arriving on the 9th. And we can see the difference here. So the fire had expanded on the 7th up to this date. And then by the 12th, we had already experienced that big fire day. So that's a huge amount of growth that occurred. And it definitely, you can definitely track that through the different monitors. Here's a kind of a graphical display of kind of how the monitors responded over September. So you have the big day on the 9th, you get the change in air quality, and you have probably 5 or 6 days of just really bad air. And then it gets a little bit better. You can't really see it here. The day that I left, we also had another blow up of wind, and the direction of the wind changed. And I do talk about that later. But unhealthy air began to be pushed actually more to the west. And here's an image of the Sonoma Valley area, but they had the same sort of sky over Willow where I was staying a couple days earlier. They had said that, 100 meters up, it was just black. So very, very apocalyptic. So again, I mentioned that we had this big day that occurred on the 23rd. So here's the day before. Have definitely fire that grew. You can see it up in the northern section and the western flank. And so if we go back and then forth, you see that the fire definitely changed. And accordingly, the air quality got poorer. So on the 31st, this is toward the end of the fire. You can still see that the air quality is still being affected by this fire and others around it. So I wanted to show you this image of that big day where the wind shift blew in gusting winds up to 30 to 40 miles per hour the day that I left on the 27th. And you can see the beginning of the day. This is kind of rolling through this, but the beginning of the day, you've got our smoke from our fires, and you can see the increase in the fire starts. We've got blowups and new places where the fire kind of took off. I want to point out this one fire right here was close to Reading, and this is the one that killed that one firefighter. Okay, so let me talk a little bit about the behavior of the smoke and the fuels. So the fuels, like I mentioned, are much different in the northern section. You've got a Douglas fir, white fir forest. You got crowning of the fires there. These are actual photos from the fire. And then in the southern section, you've got this scrub oak chaparral, which you produce this very devastating moonscape. As far as the eye can see, it was like this. I mean, if you 360, it was just everything was wiped out. Some images from satellites. You've got the Sentinel-3, the European Space Agency satellite. You can see smoke from all the different fires. This wasn't just our fire. And then on the middle two slides, they're back to back, same thing. The top one is from MODIS, bottom one's MODIS 2, but this is what's called just a natural color, and you can see the smoke dispersion off our fire right there as it goes up north. Here you can see more of the burn scars with this false color composite. And it really pulls out where the fire has actually consumed a lot of the vegetation. Here's October 4th and some images of the smoke as it's layered on out. And this is Ruth Lake. Ruth Lake is here, and this lake actually got jumped by that big day. And then this is just another image of the transport, the upper level transport of the carbon from the smoke and how it affects a lot of the U.S. It's pretty amazing. And then, just looking at the stability of air really comes into play. You've got unstable air, which, basically allows the smoke to get up in the upper atmosphere and not be a problem on the ground. But then there are these days where smoke interacts with just layers on down because of these inversions, and it can make driving very challenging. We'd have to interact with the California Highway Patrol as far as signage or closures. Many times when this smoke is mixed with fog, it becomes almost impenetrable as far as visibility. And so we had an occasion where I was driving down one of the main roads of the Central Valley and had to call into our public information and say, you've got to get some information out. This is dangerous right now. It scared me. I'd never kind of driven through something like that, but very, very, very interesting. So I've been talking about lessons learned, but I do want to mention this. By the way, these pictures are not of the fire or the area. This is a 14er that my family and I got to climb up in Colorado this summer. I just thought it was a nice picture. So one of my projects I work with looking at the effects of wildland fire on drinking water quality. And one of the variables that are put into our models is areas of exclusion of fire retardant. And in a lot of ways, it's hypothetical. If there's, in the issues when we were on that big day, they were going to drop retardant right alongside the lake, or they're going to protect their people. So what I learned is that things get thrown out when it's game on for these different fires. So we have to take that into account as far as uncertainty with the different research that we're doing. And then also just working alongside with these other professionals who are professionals in vegetation structure as well as the meteorological stuff was really, you find different ways to discern smoke. Because I didn't come in as a smoke person, so I have to learn, what smoke looks like versus what fog looks like. It's a different tone to it as far as the way it looks on the ground. And so this College DuPage is excellent, and you gather all this. Sometimes you can be overloaded with all the cool sites you're able to go to make your predictions if you're geeking out on life. And then the fuel models too. This helped me with my work is, which ones are some of the better ones. And so I was able to look at one land fire product in particular that helped me a lot with my research, as well as working on the fire itself. Looking at anomalies, we can predict, what's happening as far as smoke, and in general it does that, but there are some anomalies. This Red Bluff site was located in an area that had a depression, a creek bed depression, that the surrounding monitors were actually resulting in better air quality than this one consistently. So we drove out there and found this just maybe 3-foot depression area that really had an impact on terrain-driven smoke, which helped us a lot in understanding how to forecast that one monitor in that one community. And then finally, we have to be adaptable. In this fire, the ARA program has never been responsible for monitoring carbon monoxide, but we were able to get monitors in place and start monitoring our base camps and our spike camps. So that means on the job, just figuring out how these monitors work. We'd never used them before, and then how to read this stuff and get the information out, everything else. And I believe that's it. I am open for questions. Thank you for your time.